Welcome to The Inconvenient Truth, our second series on decarbonization, as we try to untangle the truth and consequences of climate change. The series features 3 interviews of Yogi Schulz of Corvelle Consulting, conducted by Ron Murch of the Haskayne School of Business at the University of Calgary. Both have a lifetime of experience in riding this roller coaster, Alberta's oil and gas industry. In this, the second episode, Yogi explores solutions, reason trumping emotion. Over to you, Ron.
Well, having explored the aspect of what the challenge is, and getting actually a little bit of interesting discussion going, it would be worthwhile to look at what some of the strategies might be. What's the science of decarbonization, and how does it contribute to this kind of dealing with the challenges that face us? And so in this section, that's what Yogi will explore. For a problem of this magnitude, of course, with worldwide implications, the solution actually consists of multiple initiatives and significant technology interventions. It's probably not appropriate to talk about the solution or a solution. It's probably more appropriate to talk about a series of strategies and so on. But perhaps you'd like to introduce us to the science behind decarbonization and a little bit to the strategies that we can pursue in order to address some of the challenges.
Okay, thank you, Ron. So what are some of the strategies? What is the science and the technology of decarbonization? In this section, we want to demonstrate that reason can, in fact, trump the widespread emotion that too often dominates the decarbonization conversation. The emotions include panic, that the problem is so big that it can't be solved, anxiety about the projected cost, determination to pin the problem on somebody else, outrage that the problem is being foisted on mankind by a hidden conspiracy. But we want to stay away from the emotions and talk about the strategies that achieve decarbonization. I believe it is possible, although we are unlikely to achieve it by the proposed current goal, which starts at about 2050 and in some cases extends to 2070, as we've seen on some of the previous chart. The strategies, as Ron mentioned, involve a wide range of actions that will involve every part of every economy and every society. Here's the list of strategies that we'll examine individually on the subsequent slides. Implementing these strategies on a large scale will require government policy development, basic science research to validate the government policy, regulatory development, regulatory approval of significant industrial scale projects, technology development, and last but not least, dollars for significant investment. So the first place where I think we can start, and this is often overlooked as we look at grandiose solutions, is to simply increase energy efficiency and conservation. Businesses, governments, NGOs, homeowners, all have many opportunities to increase energy efficiency and conservation and thereby decarbonize. So let's look at a few ideas. We can improve motors, reduce oversizing, implement higher efficiency motors. We can improve buildings with better lighting, windows, HVAC and insulation. We can reduce waste and scrap. We can shorten supply chains, which reduce transportation costs. We can replace truck trips with railway trips. Railways are more energy efficient than trucks. Notice how this whole focus on just in time actually takes us in the opposite direction, because trucks are more flexible, even though they're more expensive than railway. We can reuse industrial waste heat. There's lots of heating of materials that create significant waste all throughout industry. We can reduce transportation costs. Industry drives many components along the manufacturing chain on many trips that can consume a lot of gasoline and diesel. We can reduce water use. Many industrial processes use an awful lot of water. We can increase the population of densities. So businesses are reluctant, and so is everybody else, to invest in new equipment when the current equipment is not at the end of its life. We're all reluctant to change established processes and routines that seem to be working. So how should we encourage this change with a carbon tax? Some people prefer cap and trade. Others want more government regulation. But maybe this is the right thing. You know, we're all scared of the carbon tax, but the bigger problem really is climate change, not the carbon tax. So we can increase zero carbon renewable energy generation. Most of the energy generation is for electricity. We also make use of more of the waste heat that's a byproduct of electricity generation. So how can we decarbonize? We can change fuel sources for energy generation from coal to natural gas or LNG. We can increase industrial solar and wind, as you see here. However, to be effective, these technologies must be accompanied by industrial batteries and a smart grid that costs more money. We can increase solar, home, and wind. These technologies are not widespread because they're not competitive with energy from the grid. We can increase hydro and nuclear. The impediment with nuclear, of course, is a concern about radiation. With hydro, actually with both of them, they're very capital intensive to get started, even though they're cheap once you get into the operating phase. Perhaps we need to introduce more geothermal, like this example from Iceland, where the conditions are ideal. However, there are many other suitable locations throughout the world, and higher energy prices make geothermal economically viable. We can also reduce diesel for energy generation. Now, there's a lot of talk about electrifying energy consumption throughout the economy, and this is what's required here. We can change the fuel sources for consumption from this list of gasoline and other products on the left. This is a step toward decarbonization if the electricity generation doesn't produce any greenhouse gas emissions. Changing fuel sources for energy consumption from natural gas to electricity for heating, like has been started in Vancouver, in my view, is not just controversial, it's ridiculous because the electricity is inefficient for home heating. So it's almost impossible to craft a set of credible strategies, as was discussed in our last discussion period, for achieving decarbonization without nuclear involvement. This is because the decarbonization implies such a dramatic, massive increase in electricity generation and electricity consumption. The attractions of nuclear generation include zero greenhouse gas production, high energy density, which solar and wind don't have. They chew up a lot of land. They have the highest capacity factor. What that means is it's on most of the time. It's not down for maintenance. It's not missing the sun or the wind, and it has high availability. So we'll expect to see a lot more discussion of nuclear.
Yogi, I have let me interrupt you for a moment here. It seems that the sort of general orientation toward a transition to using electricity from other forms is really a physics challenge, maybe a chemistry challenge of transforming energy from one form to another, where we capture it in an easily captured form, or we have it in an easily available form, like solar or gasoline or something like that. And then we transform it into electricity. But at the same time, we want to encourage the use of electric power. Won't that mean distributing more electricity, substantially more electricity, through either existing grid or improving that? And all the while, the global population is increasing, so demand will be increasing at the same time. Is it even feasible to generate all the electricity that is required? This seems like what is generally referred to as a wicked problem or a wicked challenge, as opposed to a simple challenge. It's not easy. And it's probably going to be a huge political challenge, is it not?
I think you're right to ask those questions, because the demand for electricity will just go up like crazy. And and we'll need a lot more grids to move that electricity around. You'll see in Europe now, they're building a lot of undersea cables and more connections in the grid without adding any generation capacity, just to make that electricity more available and sharing it. We'll have to do the same thing in other parts of the planet. So I'm expecting there's going to be a lot more distributed generation. And what I mean by that is we're going to have smaller plants that are more local. They may not have the ultimate inefficiency, but they reduce the grid problem. So for example, if you look on 9th Avenue at 5th Street East, there is a small generation plant that ENMAX used to own. And I thought it was really neat. It was the latest and greatest in cogeneration, which means it made maximum use of the natural gas it consumed, and it piped its waste heat underneath 9th Avenue to heat the city buildings and Bow Valley College. So that to me is an excellent example of what I think has to be replicated thousands of times across the planet to address what you're talking about. One of the problems we have is we actually have high fossil fuel consumption subsidies. That makes fossil fuels actually seem cheaper than they are to the consumer, making it even more difficult for those consumers to switch to something else, because it encourages overuse, leading to avoidable greenhouse gas emissions. These subsidies are significant in some third world countries, like you see here. And they're also were big in Egypt and Indonesia. Both countries wisely used the recent plunge in energy prices to get rid of the subsidies or dramatically reduce them with very little consumer impact. Mm-hmm. We even have this subsidy in Alberta. We call it purple gas. Some people don't like that because they benefit from it, but I think it's an example of something we need to get rid of when we want to be serious about decarbonization. Okay, we also can introduce zero carbon fuels like hydrogen. The problem with hydrogen is what you mentioned earlier, Ron, is that we have to create it with energy to tear apart some molecules to generate the hydrogen. So we like it because it's a renewable energy source, but it's really only renewable if we generate it using renewable sources. I know that sounds a little bit circular. It has an almost unlimited supply. It's the most common molecule in the universe. It can be produced, meaning distributed locally. It doesn't have to be in big plants the way we generate electricity using natural gas or nuclear. There are no emissions. However, we still have problems with the cost of producing it, storing it, transportation. And as you know, it's highly flammable. It's very explosive. And so far, its production is still dependent on fossil fuels. So the extent of the benefit remains to be seen. To me, there's an opportunity here, but there are some people, I think, who are overhyping this.
Overhyping it what way? The negatives or the positives?
The positives, sorry. They're seeing it as a silver bullet for decarbonization.
Well, there's a major announcement forthcoming that I'm aware of in Alberta that will add another few $100 million into Alberta's investment in hydrogen. So clearly Alberta seems to feel that the disadvantages can be addressed. Maybe we'll have a Dale Naley at a future session to address that specific question or point.
Well, I think I'm not discounting this, and I'm not trying to, dismiss it. I'm just trying to avoid overhyping it.
You're not alone, and I'm not overhyping it either. But I'm saying I think the point that you've made around hydrogen is worth diving into, just as the discussions around nuclear need further investigation. So
absolutely. So I see all of these energy sources or energy generation or electricity generation alternatives. They're all part of the solution. There is no silver bullet here, and we probably whatever we can think of is part of the solution. I mean, even algae is part of the solution in certain circumstances. And you only gave us an hour and a half, Perry, which is probably the longest I can talk anyway. But there are issues that we are not discussing today, which would be interesting.
Part of the aspect that you, Yogi, and Perry are skirting around right now is how should the various governments or political elements pursue investment in a variety of strategies so that the most promising strategies can in fact be teased out of the various approaches that we have in order to pursue them in a more deliberate fashion. Like, we can't just look at single solutions. We need a spectrum. Otherwise, as a wicked problem, we're not going to learn enough as we go through solving it or addressing it.
We're going to address, I think we're going to address impediments in the third session, because I'm just itching to get into the role of government and financing and markets and socialism. So let's hold back on that for a moment. And I'm talking to myself. So,
okay.
Go ahead, Yogi.
All right. Moving on. We're going to be introducing carbon capture, utilization, and storage. There's no way around that. The problem with it is that it's, at this point, quite costly. But on the other hand, some early investments have been made. So, for example, the good people of Saskatchewan have invested $1 billion, whether they realize it or not, and built the first ever carbon capture from coal-fired electricity generation. And that CO2 is being used by Cenovus in the oil field to maintain formation pressure to improve production. So that's great. But if it wasn't for that $1 billion, it would never have happened. Similarly, in Alberta, the provincial government in Stelmach's time invested over $1 billion to spur this on. And we still have a ways to go to make this cost effective. But we'll probably have no choice but to pursue it, because all of the sources of CO2, it's unlikely that we're going to be able to prevent them all. Some will end up having to be stored underground forever.
Yogi, do you have any insights with CO2 capture or carbon capture and storage? Do you have any insights yet, or have any emerged as to the longer term implications? Are there any unanticipated consequences of underground storage?
Well, the unanticipated consequence that everybody points to is, oh, it's going to leak. And there is a remote risk of that. That risk goes up significantly if you do something incompetent. In this case, the incompetent thing is when you abandon these wells, you do that incompetently. But so long as you abandon these wells competently, the CO2 is going nowhere, because it's deep enough underground that that's impossible.
Proceed.
We'll also need to scale various technologies to help us with this. We kind of touched on the enhanced oil recovery in Weyburn that Cenovus is using the CO2 from the Boundary coal-fired electricity plant. It turns out we can also make interesting chemicals from CO2, such as methanol, urea, and polymers, if with the right chemical facilities. There are CO2 fuels that are typically made from a mixture of hydrogen and carbon monoxide that's derived from CO2 and mixed with hydrogen. That has possibilities. Microalgae, what they do is they fix CO2 at high efficiencies to produce biomass, which again are fuels and high value chemicals and use a lot of CO2, where there's been a lot of experimentation in this area, and we're still learning how to scale this up. Concrete building materials, it turns out that CO2 is very effective at curing cement to reach the strength that it needs. So expect some consumption of CO2 there. One of the reasons this is important is because there's a lot of CO2 generated in the production of cement, and everybody is looking for solutions to reduce that. And if it can be incorporated into concrete, that would be a very immediate solution. We also have the idea of facilities that remove CO2 from the atmosphere. So this is a drawing of the one that's an upscale of the one that's proposed for BC by a company that's working on that. And this is the plant that actually exists today in Iceland that sucks CO2 out of the atmosphere and injects it underground. It's not yet profitable, but it got built because of the carbon credits system that in Europe, where you have to pay to pollute with carbon, and this facility is financed by that.
As you move through these, I don't know, 7 or 8 different overall strategies that you've talked about, you haven't really mentioned any what I would call softer strategies like education or government funding of basic science or those kinds of things. Are you going to get to those a little bit later?
Education was more under the way to reduce one of the impediments. Government subsidies, I've mentioned them briefly, and Perry also talked about those, and I think they're most valuable when government funding is used to advance the technology rather than pay out subsidies for people to behave in certain ways, because that gets totally out of hand.
You know, Yogi, you, like I and many of us, have been referring to technologies as the solution. And so be it. I mean, we've lived now for 100 years where technology always seems to arrive at just the right moment. It's conceivable that this is not going to get solved technologically and that the social implications will be profound. And I think that probably sets up episode number 3, which is looming, but I don't want to dismiss Ron's point or what you will be getting to in item 3 and the discussion that will probably follow.
Yeah, so you're right. Mankind has been bailed out by technology on many, many, many occasions for literally millennia. And this time around on this problem, technology will be an important component. And I've tried to refer to some of the components, but technology by itself is not going to solve this one. So there's another interesting aspect here is what is the next generation. This generation wants action on climate change and decarbonization. They've received a lot of environmentally conscious material at school. They've heard about major environmental destructions like cutting down the Amazon rainforest, overfishing, disposal of plastics in the oceans, reduction in biodiversity, overuse of fertilizer that's changing the oceans, overuse of pesticides, killing some species and polluting groundwater. They've also been fed nonsense, such as oil and gas producers are polluting the atmosphere. Nuclear energy is so risky and dangerous that we should stay away. Fracking pollutes groundwater. Pipelines contribute to GHG emissions. We're not doing enough for the poor. Our society has too much inequality. So the next generation might not understand the costs and implications, but they've heard a lot about environmental damage in school and on social media. If we can add more energy literacy, this is that education component you talked about, Ron, to the fervor and the enthusiasm of the next generation, that will build a commitment to decarbonization. improved energy literacy will also mute the impact of wacky proposals that receive astonishing support. So what are some tactical actions that are to close in on net zero? You know, some of the items I've talked to, you know, they require new technology. They require building vast facilities. They require billions of dollars of capital. Well, you know, I don't know if we will reach net zero, if even possible to reach net zero. What I do know is that we can use our energy resources more wisely. And as we do that, we are decarbonizing and reducing other adverse impacts. So this is a list of actions that we can start on immediately. They don't require new technology, huge capital budget, long wrangles for regulatory approval, years of potentially risky construction. You know, these are things that can start today. For example, about 1 billion people can reduce their energy consumption. Well, we talked about that earlier already. Most industrial processes can reduce their energy consumption from whatever they're doing today. The most important ones are steel making and cement production, because they produce so much GHG today. Natural gas producers can reduce their GHG, especially methane. And I mentioned Russia, Iran, and the USA because they're the 3 biggest pollutants on this. Alberta can beat its chest on this because it has some of the lowest methane emissions per unit of oil and gas production on the planet and is regularly rolled out by the World Bank as an example to follow. Manufacturers can materially reduce the volumes of plastics that they consume, use less in packaging, make the packaging they do use more recyclable. Building owners can reduce their energy consumption at a very small cost in capital, and sometimes this even yields operating cost reductions. Farmers can reduce fertilizer and water consumption. I'm always astonished at how much those irrigation sprinklers run in southern Alberta, and the fact that agriculture uses half the water we consume in Alberta. I think they're very wasteful, and somebody should call them on that. It turns out that you can reduce the methane emissions from cattle by about half through selective breeding, so we should be doing that. Homeowners in the Northeast USA can replace oil heating with natural gas for their homes. That's a very little net cost and a significant benefit in reduced GHG emissions. So there's an immediate opportunity right here and now.
Thank you, Yogi. Thank you, Ron. This will conclude episode number 2, and we look forward to episode number 3, which will get into the passion and the politics associated with the impediments that loom in front of us. I might comment that, again, in the former decarbonization series, Dennis McConaughey was passionate about the point that we are not going to reach net zero, and therefore we need to adapt. But that's, again, another story. So, again, thank you. Concluding episode number 2.